Hello everybody. Today we're going to do an application of the normal distribution. Let's get right into it. Example number 2 here says it's a normal application. So let us assume that IQ scores have an average of 100 points and a standard deviation of 15. What does that mean? Well, that's why part A, the general picture. What does that question ask you to do? It asks me to draw, first of all, since we know IQ is normally distributed, we could draw this picture. Now, since it's normally distributed with 100 as the mean, I could put the mean dead center. So remember, there are two levels here. You have the real life, the x-axis, which is the horizontal line, and you have sitting above it the normal curve, the Gauss curve, the Z curve, whatever you want to call it, sitting above it. I'm going to call it the Z curve. And that spot on the Z curve is actually 0. So the real life 100-point IQ is what we call a 0 Z curve, 0 position, because you are perfectly average. You've got 100 points on an IQ test. Now, 1 and -1 are the first 2 points, and then 2 and -2 are the second 2 points, and then 3 and -3 are the third points. This is the general description of the normal distribution if you know your data is normal. What you do is you draw your normal curve like this, and you label it -3 to 3. Each one of those represents one standard deviation move. That's very important to me. This is one standard deviation move. All right? And so this is also one standard deviation. This is also one standard deviation. In the real life, what it represents is a 15-point IQ swing. So a level 1 IQ would be 115 points because it's one standard deviation above average. What we have here are boxes we like to fill in at each stage in time to represent the levels, the cutoffs, the typical cutoffs for IQ. And so what we do is we look at the mean being in the middle. The mean is always in the middle in a normal distribution. The standard deviation is how you move from one box to another. The standard deviation in this question, and you can look it up, is 15 points. And so what that means is every move of a standard deviation or one unit in the Z-score, your choice, is an extra 15 points. So if I was going from level 1 to level 2, I'd have to get another 15 points on the IQ test. So if I had a Z-score of 2, I know I scored 130 on the IQ test. If I had a level 3 in the Z-score, I know on the IQ test I scored a 145, another 15 points. Again, you start at the average and add 15 each time you want to move up the chart. Vice versa, when you start at the average and you want to move down the chart to lower IQ scores, you would subtract 15 off. Well, that would be 85 when you subtract 15 off. This would be 70 when you subtract 15 off. And this would be 55 when you subtract 15 off. So each of these stages is 15 points apart. As long as I did my algebra correctly, each one of these stages is 15 points apart. The reason why we always draw this model first, I call it the general model, is because it really gives me a practical idea of what people are. That is the normal IQ range. To me, it's right here. This is the normal IQ range. Why? Because 68% of us will score between an 85 and 115 on the IQ test. 68%. That's normal. Think about that. 68%. So if I have 100 random people to take the test, 68 will fit between those IQs. That's why it's called the normal range. You want to be a little bit more intelligent? You fit into what we call the high normal range. The high normal would be between 1 and 2, of course. But just so I can draw my picture for completeness sake, we know that 95% of us fall between -2 and 2, okay? 95% of us. So if 100 people take the test, 95 out of 100 will fall between 70 and 130 points on the IQ test. That leaves, again, this is what I call the high normal range from 1 to 2. Because if you think about it, 68% is from -1 to 1, 95% is from -2 to 2, that doesn't leave much in this area right here. There's not that many people. There's not a high chance of a probability to fall between 115 and 130. Think about how you would do that, how you would get that answer. Think about how you could use the red and the green numbers to get your answers. And simple, really. Cut those numbers in half. Cut the 95 in half. That's 47.5. Cut the 68 in half. That's 32. And subtract them. That leaves roughly 15% of us to fall here. The slightly above normal range. So we have the normal range, which is anybody between -1 and 1. The slightly above normal range between 1 and 2. Obviously, vice versa, the slightly lower than normal IQ range, -1 and -2. And then we have what we call high range. All right? Anybody that's between a 2 and a 3, or between a -2 and 3, are what we call the non-normals, the outliers, the classic outliers. If you're above a 2 in the IQ or below a -2 in the IQ, you are definitely an outlier. The reason being is because 99.7% of us will score between a -3 and 3. Now, I keep saying the Z-score, but now that I have the real-life numbers, I can actually see it. I can actually see that 68% of us will score between an 85 and 115. I know typically what's going to happen. I know almost all the time what's going to happen. If I have 100 people, almost all of them, maybe one though, but almost all of them, 99.7%, so that's almost all of 100, will fall between a score of 55 and 145. There's not many people that are going to be above a 145 in IQ and below a 55 on the IQ test. Those are the ones I'm interested in. Those are the ones we would study. We want to know, why did they fall in those ranges? Why did they fall, in some respects, above a 130? That's really important to me, because that's what I call the upper 2.5. Think about it. If 95 falls between -2 and 2, that's 95% of us. Only 5% is left for everything. And since the sides are equal, half of which is in the top. So this is the top 2.5. That's very important to me. I now know where the top 2.5 live. The top 2.5 on the IQ test, top 2.5%, live at scores 130 and above. And vice versa, the bottom 2.5 in the world lives in scores of 70 and below. Those are what we call the classic outliers. Anybody scoring 70 and below, because the chance is only 2.5%. And anybody scoring above a 130, because again, the chances are only 2.5%. Think about 2.5, 95, 2.5 add up to 100. That's why I keep saying the 2.5, that makes 5. That's the opposite of the 95. 95 inside leaves 5% outside. Awesome. I always like to draw this picture in big, bold detail prior to do any question, because every question kind of stems from here for odds and probabilities. Once I get this picture locked down, really, no question should scare me, especially for IQ. Now, let me let you into a little secret. I don't care what we're actually talking about. I can change the numbers in this box and talk about anything else you want. You can say these could be the salaries of an employee. The average salary is $100,000 with a $15,000 standard deviation. That means the typical person makes $100,000, but the average range could be anywhere between 85 and 115. And it is very unlikely to see anybody making more than 145 in this position, whatever salary position we're looking at. I can change the application, but as long as I know it's normal, the only numbers I have to change are the numbers in the box. The red, the green, the blue, these are all done via calculus, and calculus doesn't change. The numbers in the box can change, and that's cool. So once you get used to really drawing this general picture, you have a good idea of anything, especially when it comes to normal. So we just checked off the normal picture. All right. Now we want to talk about parts B, C, D, E, and F. real world problems. Real world problems. That is, what is the probability a random person scores less than a 120 on this test? What are the odds somebody's going to score less than 120? So I would write that in symbols, the odds a person, X, scores less than 120. All right, well, I have a procedure for this. Of course, I'm a logical person. My procedure is, number one, draw a crappy picture. It's normal because we said it was normally distributed. 120 falls right there. So I know it's going to be up here on the high side. Less than means shade to the left. Got it. So I know the answer is going to be pretty big, all right? And if you really understand this chart, you probably have an idea of how much the answer is going to be too. But let's go down to here. Notice 120 is not on the chart, so I can't just look on the chart. I have to think of a logical procedure for finding this probability. Well, now that I know it's 120, the second thing I got to do is turn it to a z-value. You see, this is the real-life value, 120 points. That's not good. There's no real-life table for IQs. There might be, but I do know one thing. There is definitely a z-table. And if once I know the z-table, then I know everything there is to know about areas and probability. So if I can line the x value up with the z value, I'm golden. And that's why in step 2, you always pick the formula you need. And the formula you need in this case is x minus mu over sigma. The good news is you know what mu and sigma are in this question. They have to be given. The mu is the average. The sigma is the standard deviation. So notice we already have a nice, easy formula called a transformation. I can transform any x value into a z value by just plugging in the x. And that's really what I do. I take the x value, plug it into the transformation, the z formula, and out pops out the z value. So I plug in 120. 120 minus 100 is 20. 20 divided by 15 is 1.333 repeating. We'll just need 2 decimals, 1.33. And that is the number, if you watched my previous video, I'll go to the table with. Or I'll go to Excel, your choice. Since we have the table, let's just brush up on the table. You go to the table with 1.33, 1.3, go over to 3, so 1.33, and you get 90.82. So 90.82. And what I always tell everybody when they're reading the table is make sure they understand the table. The table was the area to the left. So in my step 4, I always pause and say, is that truly what you wanted? The area to the left. Well, let's go back to the crappy picture. Well, gosh darn golly gee, that is the area we wanted. The area to the left, because that's what the less than is the area to the left. Which means this is the exact answer I was looking for, 90.82%. Nice. So there's a 90% chance that somebody's going to score less than 120 on this IQ test. So if somebody needed to know this for research, I could easily give it to them. What are the odds somebody's going to score less than 120? 90.82%. That is my answer. 90.82%. So I'll have a little answer column here. I'll start to build. How did I find it? I went to the table. Now, do I have to go to the table? Of course not. You could use norm S dist. This is the only one I use. But to use norm S dist, you need the z value. Please notice you need the z value. So I'm going to erase here. I'm going to have a column titled z. If you can give me the z value for 120, then I can work with it. So in fact, I'm going to start with, do I have an x value? Of course I have an x value. The x value is 120. Can I turn that x value into a z value? The answer is, of course I can. All I got to do is take the x minus the mean and divide it by the standard deviation. And that will transform it to the appropriate z value. And then I can go to the table, i.e. norm S dist, and look up that z value. And recall, you always want 1 when you're doing the normal distribution. If you're doing cumulative, of course. There's sometimes you might do probability density function, but you're in higher level statistics. I'll let you deal with that when you get there. For us in first level statistics, we always want a 1 there because we want to add the area total down. That's really what the 1 does. It adds all that area up, does an integral for us. Boom. Notice we get the exact same answer as here. This is the most accurate answer, 90.8789. But because of the table, we had to round, and our answer is 90.82. And that's good enough. You want the most accurate answer? Yes, of course, we have Excel. So instead of table, let me call that Excel. All right. Why don't you try the next question before I get to the answer? That is, what is the probability a random person scores more than 140, which is better known as a genius level? What does it take? How many people score more than a 140 on the IQ test? So how many people are at a genius level or higher according to the IQ test? I'd pause the video, try it out, and then watch me do it. All right, let's do this. More than 140. Here we go. Now that we know how to do 1, you know how to do the rest because they're exact same way. Real life, more than 140 to be a genius level. All right, I like to follow my steps. Step 1, draw a picture. Plot 140. Well, the great thing is when you have a master picture, you get the idea. 140, you're up there. You're in the outlier range. Well, come on, geniuses don't just occur everywhere. Of course, that's going to be an outlier range. The z-value is going to be pretty far up there. And in fact, I know it's between 2 and 3. How do I know? Look at it. 140 is right here in between these numbers. So I know 140 has a z-value somewhere between 2 and 3. And if your z-value is above a 2, you are a classic outlier. If your z-value is above a 3, you're an extreme outlier. All right. So how do I find the z-value? Well, it'd be great if we had a transformation, and we do. There is a standard transformation formula that turns any z into x and vice versa, any x into z. You just got to tell me the average of your distribution and the standard deviation of the distribution. Those should be well known for what you're studying. If not, you got to find them. You got to find the average and standard deviation of the distribution. All right, so here's my z-value or z transformation formula. I will plug 140 in and out will pop out. Well, it's going to be 140 minus 100, so that's 40 over 15. And so that's my z-value. And if I take 40 divided by 15, I get a whopping 2.67. And that's to be anticipated. We knew it was a number between 2 and 3. Now that I know that number, I will then, you could go to the table, but because we have Excel, now that I have Excel, I could do NSD, norm S dist of this number, comma 1, and see what we get. See what answer we get. So let's check that out. Let's go to Excel. So I know the X value was 140, level of genius. I know the Z value by formula is X minus the mean. We keep repeating this so you learn it. X minus the mean divided by the standard deviation. Got to do your order of operations correctly in Excel or you're in trouble. Put a parenthesis around the numerator or you're in trouble. Enter. So 2.67 like I got. All right, now Excel, norm S dist, abbreviated as NSD, norm S dist, you hit your Z value, always turn on the cumulative ability, and boom, you get 99.62. 99.62. So let's go back to the problem. By NSD, I get 99.62. You should get something very similar if you went to the table. Number 4, my pause moment. I always have 4 steps in these questions. So my pause moment. 99.62. 99.62. Remember what we wanted. We wanted this area. I don't think 99% of the population are above 140 or geniuses. People might think they are. But instead, I think the 99.62 is what's below. 99.62% of us are below genius level. Because again, the table or norm S dist gives you areas to the left. I don't care if you're looking at the table or if you're looking at Excel, norm S dist gives you the area to the left. Honestly, all the dot dist in Excel gives you the area to the left. That's a very nice thing. It always does the same thing. So when I'm doing a question about more than, I keep true to my principles. If I want more than, it's 1 minus the area below. And that becomes a very small number, which is what I thought it should be. And I got to be careful there. That's 0.0038. That is less than 1%. Heck, it's less than 0.5%. Not many are at genius level. But come on, if you're going to be at a genius level, it can't be easy to be at a genius level. Now, how would I get it from Excel? You just got to understand, if I was doing an above question, you would do a 1 minus. And that's why my answer is 0.00, so 0.00383 is my answer. And then you can change it to decimal just by clicking here. If you notice, I'm going to have to add some zeros so I see accuracy. Awesome. Second answer done. All right, guys, put on pause again. Try your hand at the next question. Probability between 80 and 138. What are the odds a random person walks in, takes the IQ test, and scores between 80 and 138? All right, we're back. Let's try it. 80 and 138. Let's do it. Probability 80 and 138. I always like to verify so I don't go down the wrong path. Awesome. So how do I do a between? And if you think about it, I'm doing the 3 classic examples. Area below, so probability below, probability above, probability between. These are the 3 classic questions. You just keep hammering them until you get really good at doing all 3. And they're all done the same way. Draw a crappy picture. Why do I draw a picture? So that way, in my pause moment, I have an idea of roughly what the area is. 80 and 138. My picture's way up here now. 80 and 138. All right. So 80 is down here, but 138 is pretty far up the chart. So I know this area is pretty large. Okay, what do I do now? Step 2, change these to z. How do I do it? X minus the mu over sigma. How do I change this to z? X minus the mu over sigma. Think you've heard it enough for me today? I hope. Why do we want the z value? Because we have a table for the z value. Again, here's the x, the real life. Sitting above it is the z curve. I'm trying to find the matching z values for each of these x values. So 80 minus 100 is negative 20. Divide by 15 gives me a whopping negative 1.33. 138 minus 100 is 38. Divide by 15 is 2.53. And those make sense if I could get to the master picture quickly. What they represent, though, is positions. If you scored 138 on the IQ test, you are 2.5 jumps above average. That's really what it is. Again, the Z represents standard deviation jumps. You are over 2 standard deviations away from average, 2.5 to be exact. Wow. Anybody outside of 2 is really an outlier. So a person score a 138, good job. Vice versa. What about an 80? Well, an 80, you're just under normal. Normal would be a -1, so negative 133 is just under normal. I'm not really worried about somebody here until they get to a -2. Once they get below a -2, I do have to worry about what that means in terms of their mental state, IQ state. But because this negative, and it's okay to be negative, by the way. This might be our first negative Z value today. A negative is okay. It just means you're below average. A negative Z means you're below average. And it's okay sometimes to be below average. For example, if this picture was debt, I would want to be on the low side of debt. If this was credit card rates, I'd be on the low side of credit card rates. If this is reaction time, I'd like to have fast reaction time. So down here, not slow reaction times. All right? So there are times a negative Z score is very good to have. In this case, we're talking about IQ. I'd rather be up here. All right. So once you have the Z values, what do? Well, now that we have Excel to do the table for us, we dump both -133 and 253 into norm S dist and see what we get. So we dump both of those into norm S dist and see what numbers come out. All right, let's go to Excel. So we have two x values, so I'm going to insert here because I have two x values. I have what do we have here? 80 and 138. First, I'm going to turn those into z values by utilizing the formula that x minus the mean divided by the standard deviation, hit me baby one more time, will give us the z value. So again, x minus the mean. By the way, I'm stressing this one because this is important when we're talking about one random individual. If you're looking at groups, you're doing a sampling mean, which is a future video. A sampling mean, you do the same structure as I'm doing, but you got to pick the right correct formula for a sample. See, we're studying one random person. What if I wanted to study a group of people and their average scores? We'll talk about that later. All right, so now I hit it with norm S dist, norm.s.dist of the z value, comma 1. And same thing here, norm S dist of that z value, comma 1. And we get our numbers. 0912 is one of them. 0912, 0912. That should be the number we get if we look in the table. 9944 is the other. So as a check and a practice about tables, go look these up into the tables and make sure you can see how to get these numbers. Go look up -133 in the z table, get this number. Go look this up and get this number in the table. Make sure you could do the table. Now, if I want between, we just got to remember or recall, to do a between, you just subtract those two. And that's your answer. We subtract these two. This is the area below a 2-5. This is the area between this is the area below this. So the probability below this, the probability below this. Since this includes this, when you subtract them, you get rid of the area you don't want. And so our true answer will be these two subtracted. In Excel, when I want to do a between, I would subtract the two areas. See my previous video on normal to see why that makes sense. So our answer in this case would be 90%. So 0.9031. 9031. Excellent. Change that to a percent. Add some decimals. And we're good. So there's our part D answer. Those are the three classic questions. How to find the probability below, probability more, probability between. Let me just finish off my thing. 90.31. So it's a pretty good chance. There's a pretty good chance the next random person that comes in takes our IQ test and they're going to score between the bounds of 80 and 138. It is a 90% chance. Good odds. And we always want to know odds. The odds of the next person doing this. The odds the next person will buy this, satisfy this, rate this. It's all about what we want the customer or patient to do. If there's a 90% chance the patient or customer is going to do this, then that is a high outcome. All right, let's keep going. There are, again, typically 5 questions people want to know when it comes to normal distributions. Probabilities, 3 of them. Less than, more than, between. And then there's these cutoffs. We always have cutoffs on IQ charts, weight charts, blood pressure charts, about what's a high level, what's a low level. So let's start with this, top 2%. Mensa is an community, what's the word I'm looking for? A community, a place where you can sign up if you are really, really intelligent. To get into Mensa, you can be part with the same people that have high IQs. But to be part of Mensa, you have to show on an IQ test you're in the top 2%. So the question is, what does it take to be in the top 2%? That's what I'm trying to figure out. So this would be the probability above, right? Top 2%, 0.02. What's it take to be in the top 2%. Think about that. All right, let me think about that. I want to know the cutoff for the top 2%. I draw my quick picture. I know your score has to be pretty far up the chart to be in the top 2%. So this X value and Z value have to be pretty large. How do I find them? Damn good question. Remember, we want X. That's the real life number. But what we're going to do is we're going to attack this question by getting Z, and then Z will get us X. That's how we're going to attack this question. So first, I'm going to try to get Z. The good news is, so step 1 always is a crappy picture, just to get my bearings in the question. Step 2, I want to find Z. Well, come on now, you can use the table, or you can use norm S inverse. Norm S inverse says you give me the probability below, and I will give you that Z value. And that's awesome, by calculus, of course. It will do the calculus. If you give you the area below, it will give you the Z value. I keep stating the area below, because you don't have that. Or do you? The answer is you do. It's 98%. Think about that. How much area is below the top 2%? 98% of the population will score less than this score. That's what we're looking for. I'm looking for the IQ score that 98% of us cannot get to. I only want the top 2%. I want a very, very highfalutin club. I want the coolest kids in the world. Where are they? What is the IQ number to put them into the awesome club, as we'll call it? Well, we need to find this number out. Good thing is we have at our disposal Excel. So if I want to find the Z value, if I know, well, first of all, I know the area below, right? 0.98. And knowing the area means I can use norm S inverse. All you got to do is tell me the area below, and I'll tell you the Z value. 205 is my 2-digit answer for you. 205. And so that's the Z value in this picture. But once we have the Z value, we're home, because we have this formula. We have this transformation, as long as you have the mean and the standard deviation, of course. But we have this transformation. And if you have the Z, then I could do algebra, you're right, algebra, to find my final answer. So let's set this up. All right, time for some high school algebra. How would one solve this? I'm pausing because I want you a chance to do it. Okay, I'm back. What I would do is I would cross multiply. I would actually take the 15 and multiply it over. And that gives me this when I cross multiply. Then I take 2.05 in my calculator, multiply by 15, and I get 30.75. And to solve this, to solve for X, I would add the 100 to both sides, giving me the IQ score I'm looking for is 130.75. That is the IQ needed for that person to be part of Mensa. So now I don't have to do any more math. I could just say, hey, take the IQ test. If you score a 131 or higher, you're in the Mensa. If not, sorry, try again next year, or whatever, how many times you're allowed to try in a year kind of thing. I don't know what the rules are. These type of bounds are often asked in all real-life questions to allow us to be in certain types of categories. We utilize cutoffs to put people into categories. Can I do this in Excel, by the way? The answer is yes. You just got to understand. What is the formula? The formula is you take the mean, add on the standard deviation, which in this case is 15, times the Z value. And that's where I get the 130.8062. That's all I did, is I multiplied the Z by sigma, because that's to cross multiply. So actually I multiplied the sigma, the standard deviation, by Z. Then I added over the 100. The good news, it always works. The mean plus the Z times sigma is our sort of transformation formula to go from cutoff to real value. Again, the value in this number is huge. Think about it. The top 2%. In this case, who cares? You're part of Mensa or you're not. But let's say you wanted to be part of the club that gets the bonus, and the top 4% get the bonus. Or if you're looking at a disability and it says the bottom 3% are going to be marked with this specific disability. Welcome to the DSM manual. The DSM manual, one part of many parts of the diagnosis would be cutoffs, whether it be upper or lower level cutoffs. How do we get to those cutoffs? You first got to know it's normal, and then you got to decide where the cutoff is. You want the top 2%? I know how to work with that. You want the bottom 4%? I know how to work with that. And what we do with these tops and bottoms is we can either fire them, hire them, give them a bonus, put them in remedial work, put them in the honors club, put them on academic probation. There are so many real-life applications once you understand how to find cutoffs. So how do I find the cutoff for the bottom 4%? Well, I already know what the bottom is. It's 4%. To find a Z from the bottom 4%, you would just use norm S inverse on that number. Again, think about that. This is the bottom 4%. Norm S inverse says you give me the area below. You give me the area below. That's the bottom 4%, the area below. Norm S inverse says you give me the area below. I will do the calculus needed to find the bar whose area below this bar is 4%. That's what this is. Negative 1.75 on the Z chart would be the bar where 4% of us are below. 96% of us would be above this number. Once you have the Z, then you can use the formula backwards. That is, you can take the mean and add on the standard deviation times the Z value. And I now know if you score a 73 or lower, you're going to be in the bottom 4%. Again, a 73 or lower puts you in the bottom 4%. And that makes sense. If I go back to my master pitcher, all right, it's got to be a low score. That's the great thing about the master pitcher. You can get a quick understanding of the whole scenario if you have that master pitcher to start with, all the way back at the beginning, right? Understanding just where the cutoffs are. Bottom 2.5% is right here. So somebody in the bottom 4% is just a little bit better. And that's what we got. We got 73%. Sorry, 73 points. That's the IQ is scored in points. Notice the bottom 2.5% is 70 and below. So I can understand the bottom 4% would be 73 and below. That makes sense. It lines up logically. Top 2%, well, that's almost on my chart. The top 2.5 is on my chart already. The top 2.5% is 130. So 130.8 makes sense. 130.8 is just, right, top 2.5%. Top 2% is just a little higher. So just a little higher would be the top 2%. So Mensa, they want a little bit higher than an outlier, 131, just a little higher than an outlier. Okay, hey, if you build a club based on IQ, you can decide whatever bar you want to put. Top 5%, bottom 8%. Top 7%, bottom 17%. Your choice, really, when you describe who's in the honor roll, who's on academic probation, who will get hired, who will get fired. All right? It's all about, once you understand your distribution, you can really get into the nuts and bolts of the application. Who is really high on the chart that could potentially be a DSM diagnosis? It all depends on which number you want to associate to that diagnosis. Cool. All right. So we have one more question to deal with. Example 3. So I'm pausing, and what I would do is I would pause and let you guys try it, and then I'm going to try to get the answer for you. So let's pause the screen, and you try it. And then I will see what I can do. This is kind of like a challenge question. So, all right, let me go on down here. Let's do a challenge question. Example 3. What's it saying? A 2-year warranty on a product will replace a broken product free of cost. Cool. Store makes $20 in profit if the product does not break during warranty, and a loss of $10 if the product breaks during warranty. The lifespan of the product is normal. That's very important. The lifespan of the product is normally distributed. with that information, what else do we know? The lifespan of the product is normally distributed with a mean of 40 months and a standard deviation of 16 months. That's very important to me. This really just draws the product lifespan to me. So 40 months, 16 months. I'm going to take a quick little break there and think about, all right, I know the product lifespan. If the average is 40, that goes directly in the middle. And knowing that the standard deviation is, once again, 16 months, I know this is at, that was weird. I know this is at 56 because sigma is how you move in the chart. 16 months, and then another 16, what would that be, 72? So I know the product should last easily 72 months. Easily, because that's, that might be a little pushing it. If the product lasts more than 72 months, now you're getting into the, you got lucky. On the low side, if we take off 16, because that's, again, I want to make sure I got the standard deviation right, 16, where'd we be? We'd be at 24, the low side. And then take another 16, we'd be at 8. So I know the product, 95% of the time, the product will last between these two numbers. That's very important. 95% of the time, the product's going to last somewhere between 8 months and 72 months, okay? It will last. It is very, very unusual to see it last less than 8 months and more than 72 months because that's the product's lifespan if it's normally distributed with a mean of 40, standard deviation of 16. Now, let's get to the question. What is the probability the product will break during the warranty period? I keep misspelling warranty. I apologize for that. Not a big deal, but to me it is. So what is the probability the product will break during the warranty? We're having fun spelling today. During the warranty period. How can we figure this out? What is the probability the product will break during the warranty period? All right, what is the warranty period? The lifespan of the product is normally blah. A 2-year warranty. It's a 2-year warranty on a product. So a 2-year warranty. So that means 2 years. So we're talking about up to here. 2 years, 24 months. And the warranty is for 24 months and below. 24 months and below. This is the warranty period. So the question is, what are the odds a random product will break during there? So that's the question. What is the probability my product will last less than 24 months? The good thing is, I have a picture. I have not only an X value, I actually have so nicely the Z value. Because usually, step 1 is to draw a picture. Step 2 is to get the Z value. Well, I get lucky here. It's -1. If I didn't get lucky, I'd do the transformation formula. I would do the real life minus the mean divided by the standard deviation, which, by the way, again, is -1. So I get the Z value. Once I have the Z value, then I would go to the table, or I'd hit NSD of the Z value, and I'd find out the area below. Well, good news is that's -1. And I know 68% is inside of -1 to 1, because that's just one of those numbers we know. 68% is inside. If 68% is inside, 32% is outside, half of which is below. So I'm guessing this answer is 16%. But let's check that out. Let's see how you could do it in Excel. Well, again, you know the X value. You do know you want to make it to 24 months or less, because that would be the warranty period. The Z value for this X value. Well, the Z value would be the X value minus the mean here, which is 40, divided by the standard deviation. I like to always do the same logical work over and over in my videos. Got it. From there, I can tell you the area below a Z value by doing norm S dist. And so the most accurate answer for the area below would be 15.86%, which, when you round, is 16%. So I know my nice easy round, the answer was 16% chance. Again, the accurate answer is 15.865% if you care. Awesome. So that's the answer to part A. The probability the product will break during the warranty period is 15%, just over 15%. Alrighty. So how can that help me figure out what is expected profit of the store? Pause and give you guys a chance to think about that. This is part A. Part B. What I would do is I would do an outcome and probability table for that outcome. There are really only two outcomes. Either it doesn't break, and that means you make $20 of profit, or it does break during a warranty period and you lose $10 on the product. The odds it's going to make it through and you don't have to break is 15%. Sorry, I'm wrong on that, because that's the break. That's why it's always important to understand what you're building. This is the chances it breaks, right? That's your outcome. You pay $10 if it breaks. If you're the store owner, you pay $10 if it breaks. The odds of it breaking in warranty period is 15%. It doesn't break and you make a profit is right here. The odds of it not breaking is, well, 1 minus the odds it's breaking. So the odds it doesn't break is 84%, just over 84%. If you recall from my previous videos, to find expectation is the summation of x times the probabilities. So first, I'm going to multiply x times the probabilities. And then the sum of those two is the expected payoff amount, which I'm looking for in part B. This is a great way to tie in my general distribution video with the normal distribution. So what am I expecting profit to be? $15. I expect a $15 profit. Seems like a good deal. Seems like this warranty is a good deal. Now, if we sell on average 30 of these products every month, what is our monthly profit? Well, if we sell 30 of these per month, then we just got to do 30 times the average per product. And so I know the total profit in the month will be $457. And that means this is a good deal for us. Our pure profit from this product is $457. But to answer this question, I had to understand how to deal with normality and probabilities. Normality and probabilities lead me to a really good real-life scenario. What is expected profit? Well, once you know the two scenarios, break and does not break under warranty, and their cash amounts, you can come up with expected profit. From there, if you know how many products you sell typically, you could come up with total monthly or yearly product profit. All right, guys, thank you for watching my video.